Hey, Vlad here, devinside.com. Welcome to another video. In the previous video, we talked about for comprehensions, and in the videos before that, we dived way too deeply into recursion and trampolines. It's time to swim back to shore and get back to our awesome collections library. As always, we're in the Ubuntu virtual machine and we're using Sublime Text, the editor of my choosing, with a wonderful plugin called Terminus, which emulates the entire terminal for us, which runs SBT, which reruns the test every time we save the file. And by the way, guys, I'm going to be traveling soon, so I'm downsizing my setup a little bit. So I hope the sound from this headset is good, and I also hope that it doesn't ruin my hair. Alright, so in the previous video, I said that we're pretty much done with the sets, and I sat down to write a script for the video about maps. But then I realized that we're actually mixing sets with trees. So today we're going to do a lot of refactoring and we're going to rip out the trees out of our sets. I'm not going to lie, it's not going to be the most exciting video. In fact, I knew that one day we're going to have to record it because I added this method called render, remember, where we are rendering trees, and I even put tests for this method in the file called tree suite, this one, right? So I knew that this day would come. I guess they call it work for a reason. In any job, there's sometimes a task that just needs to get done, and there's nothing spectacular about it. In fact, one of the reasons why I created this YouTube channel is to show you, quote unquote, the real software development. Yeah, enough talking. Let's just get started and get it over with. So we're going to begin with seemingly meaningless refactorings, and then we're actually going to do something more, a little bit more exciting. So the first thing we're going to do is I noticed that in the set in line 3, we're still importing trampolines, even though we're not using them at all. Also in line 44, where we're adding elements to our set. We're pattern matching over here on a non-empty case, and we're assigning the non-empty variable to this pattern. So I think it's a bit neater if we use it over here instead of using this. So basically, if we're already inserting an element if we're inserting an element that already exists, we can pretty much return the set as it is. And over here we're using the non-empties, and I decided that it's better than using this for some weird reason. The next thing that we're going to do is we're going to go to the set suite, and in the line 616 I named all of these toString methods in somehow weird way. So what this one should say is this. I'm gonna copy paste a bunch of stuff because I don't want to waste your time. But the whole reason why I'm recording this video, well, not the whole reason, but one of the biggest reasons why I'm recording this video is because I sort of promised you guys or myself that I'm not going to touch this library off the camera, so I'm only going to do refactorings in front of the camera, and I'm always trying to not have them, but the same as in real life. Sometimes if you don't refactor, your code is just going to get messy and messy and messy. So we're going to do this. We're pretty much done with the set suite. The next thing that we're going to do is we're going to go to the foldable factory. The thing that we're going to touch on in the next few videos. We're going to talk about maps, and I had this comment for a while there, and I said, okay, it's technically not required. It's technically not required because it's not used anywhere in this trait. So I'm pressing Control D now, and the cursor doesn't jump anywhere because remove is not being called anywhere over here. So what I decided to do is I decided to remove it from here. So all the foldable factory needs is the add method. So that also means that if we save now, because I prefer to use the override keyword, we need to go to the set again, to the line 51, and we're going to need to remove the override like this. Okay. Let's see what's the next thing. Okay, we need to go back to the foldable factory to the line 12. And so we have filter not, which calls filter right away, and I prefer it to be read as a book sort of, so top down. And then there's this was filter, which is in the middle. So I'm just going to take was filter and I'm just going to bring it down under the filter. Right. So these are the few meaningless refactorings that I mentioned. The stuff that we're going to do after that is going to make a bit more sense. The next thing that we're going to do is we're going to go to factory. And we have a method called empty, and because everything that we've been doing so far has been covariant, we don't have any parameters over here on empty. So I decided to rename it to nothing, and instead to have a function called empty, which actually will take this parameter. I'm going to call it element, and it will produce the subtype of foldable factory, and with this parameter. And what it will do, it will just call nothing. Right, and we're going to make it a final def. Now, obviously, a bunch of code is not going to compile now, but we're going to quickly fix it. So we're going to go to set 142, And okay, so this is the companion object, and it says the empty. Where is it? Okay, over here. So we just need to rename it to nothing, and it should be fine, at least over here. And now we should have like around 15 arrows in the set suite. Yeah, so we're gonna go to set suite. So we're gonna start from the bottom. We're gonna go to 559 over here, and we're gonna rename this one to nothing. I'm just gonna copy that and paste it over here as well. 598. Then we have 564, which is over here, and 563 over here. Let's scroll up a bit. 513, 513 over here. This one should be nothing. 509, which is over here. 451, which is over here. What else? 241, 241 over here. 198 over here. 157 over here. Oh, I know this one. It's a lot of copy pasted stuff. Not good, but what else? 151, 150. Oh, I think that's it. So let me scroll down a bit. Let me save that. Should be fine now. Okay, 598, 598. What did I do here? Oh, skip these ones. There we go. All right, the next thing that we're going to do is we're going to put all the tasks in the package. So what we have been doing so far is, so we're in the tasks, so we're in test Scala homegrown collections, but the tests themselves, they're not in the homegrown collections package because I wanted to simulate what our users would be doing. So first of all, we're going to assign them to a package. So I'm going to say that this is in the package called user, and we're going to do the same thing everywhere over here as well. Package user, come on, package user, and tree suite as well. Package user, and now we're going to go to the containing folder, and we're also gonna move them to user. So I'm going to rename this one to user. I'm going to cut it out. I'm going to go back to Scala. I'm going to paste it in. I'm going to remove the homegrown over here. Right. So Sublime did not notice these changes, so we need to close these files. I'm just going to close all of them like this, and we're going to go back to user. And by the way, Sublime sometimes does not refresh these, so what you can do is you can go to project and you can see refresh folders, but in this case we were actually lucky. So so they're now in Scala user and so on. The next thing that we're going to do is, because in the next few videos we're going to start working on maps, and we're going to write tests for maps as well. We're going to go to set, and at the bottom we have sorry, not set suite. And at the bottom of the set suite, we have this company role, employee, and consultant for the test for variants. So what we're going to do is we're just going to cut them out. I'm going to cut them out. I'm not going to save the file because I want to preserve compilation as long as possible. So I'm just going to create another file, and I'm going to call it company role .scala, and it's going to be saved over there in the user, which it didn't. Hold up, what happened? Where is it? Same thing, maybe project. Refresh folders. There we go, company role. I don't know why it's all of a sudden this started happening. All right, so I'm going to paste them over here, and I'm going to put them also in the package user over here. So now I can save that, and it's going to say, hey, it's already defined. Now I'm going to go back and save this, and then everything should be fine again. And the next thing we're going to do is, in the set suite at the very bottom, we also have those generators. So what I'm going to do is I'm going to create a package object. So I'm going to create a package object, package Scala. And same thing, I don't understand why, but okay, refresh folders, there we go. Okay, so we're going to create a package object user, and we're going to go and we're going to take all of these private defs over here that generate employees or strings or so on and so on and so on. I'm going to cut them out. I'm not going to save the file. I'm going to paste them over here, and I'm going to remove the private identifier, so they're going to become public. And that's it. We're pretty much done with this file. And we're going to save the set suite, and everything still should be fine. Okay, the next thing that we're going to do is, let me actually collapse this and close the set suite. So we're going to go to the Scala file, and remember when we had problems with pattern matching, in the sense that the quality was expensive for sets, and I said that we shouldn't use pattern matching too much. And for the methods like is singleton, for example, we just had a declaration in the trait itself, and then in the implementations, for the non-empty case, we implemented it over here, and for the empty case, we implemented it over here. So now we're going to revert that, and we're going to put the declaration and the implementation into the trait. So I'm going to go back to the is singleton, and I'm going to make it a final def. final def is singleton, and I'm just gonna pattern match on this, and I'm gonna say, okay, if it's empty, then just return false, and otherwise, if it's not empty, what is left, and right, we're just gonna return left is empty and right is empty, right? Because if both of them are empty, then it is a singleton. And now I'm just gonna go here. I'm gonna remove these, and I'm gonna remove these. Is singleton. There we go. Quick save to rerun the test. And the next thing that we're gonna do is we're gonna do the same thing with the function called sample. So I'm just gonna go here. I'm gonna make it a final def as well. Same routine. So just gonna pattern match, and we're gonna say if it's empty, then it's none. Otherwise, if it's not empty, and this is pretty much the mirror of what we just did. In this case, we only care about the element, so we just wrap it in a sum, and we're pretty much done. Let me go to the sample over here. Let me remove it. There we go. And this one as well. Let's save the file. Next one that we're going to do is actually toString. So we don't have the declaration of toString in the trait because it comes from any. So what I'm going to do is I'm just going to cut that out over here, and we don't even need this over here now. All right, so I'm gonna find hash code, and because equals hash code and toString, they're coming from any, so I'm just gonna paste that in, and I'm gonna say final override def toString equals, and the same thing, I'm gonna match, right? And I'm gonna say if it's empty, then we're just gonna return that wrapped in a string, obviously, and otherwise, if it's not empty, and we have left element right, arrow to the right, then we're going to do that, and that should already be fine. We should need to go down to bottom and remove the empty one like that, and that should still work. All right, so that's pretty much it, and the rest of what we'll do is we're gonna rip out the tree out of the set. So I'm actually gonna commit that real quick. Gonna open another terminal over here like that, and we're just gonna add everything and commit everything. It's video 19. I'm just gonna call it refactoring. Come on, 19 refactoring like that. Get status. It's all good. All right, so we can close this one. Okay, so the way we're going to do this is I'm going to mark everything. I'm going to copy that, and I'm going to create a new file. I'm going to save it as tree.scala, and it should save it all over here the same way, where we have our sets. I'm going to paste everything in, and I'm going to go to the top, and I'm going to find the first occurrence of set, and I'm going to press Control F, and I'm going to say that I want to do case-sensitive search. So what I'm going to do here is I'm going to press Alt F3, and it's going to mark set everywhere, and I'm just going to replace it with tree. There we go. I'm not going to save the file for a while because it's probably going to break compilation. Actually, let's just try that. Why not? We don't have any tests for the tree. Okay, so it compiled. It's all good. So now we're just gonna go walk through this and remove the methods that that are more set-like and have nothing to do with trees. For example, sets are basically a function from the element to Boolean, right? It's basically contains, but trees have nothing to do with that. So we're just gonna go to the apply method and just gonna remove it, right? And at the bottom we have an implicit that that basically says, okay, a set is essentially a function, and we're gonna go down and we're just gonna remove that as well. Just this implicit. There we go. It's removed. Okay, so the next thing that we're going to do is we're going to go down and see again, like what is not really set like. So a tree can still have contains. It's fine. Let's go down. Fold, sure. Add. We will keep add, but in fact we're going to change add a little bit because trees have nothing to do with those duplicates, right? So trees are fine with duplicates, but we're gonna fix that a little bit later. For now, we're just gonna remove the things that we don't need. So we got union. We're still gonna need union because we need union in the removal, but we don't need intersection and difference and so on. So I'm just gonna put my cursor over here, press hold Control Shift and press K a bunch of times until we remove difference, and is subset off and is superset off, and actually equals. We don't need to override equals because Because remember, like sets, they don't have an order, and for sets, it's only important that the same elements are inside. And but for trees, order actually matters. So the default implementation that we get from the case class is actually fine. I'm gonna leave hash code though, simply because I want to have more control over it. Usually, it's not ideal to override like only one of them, but in this case, we sort of know what we're doing, so it's all good. The thing is, I believe that the default implementation for the hash code, it will return you a different hash code every time for an empty case, but I'm not 100% sure. So that's why I just prefer to put a 41 in there. It's a prime. It's all good. All right, so let's just go keep going and see what else we can delete. So we don't need toString. What else? Is empty? Yeah, is empty is fine. Non-empty is fine. Singleton, we don't need any of that. We don't need singleton. We don't need sample. Has nothing to do with trees. In fact, like these I added just for fun. And now we arrived at rendered. And that's a cool thing because now we can go to the tree suite over here, and we can say that we're not actually going to use sets over here, we're actually going to use trees. So everywhere we say set, we're going to use trees, and everything should still be fine. And now I should be able to go to set and remove the rendered method. I'm going to collapse it like that, just going to mark it and remove it like that, and everything still should be fine because now our tests are testing the trees. So it's all good. Let's go down. What else? What else do we have? All right, that's fine. Now the pattern matching on the trees is actually super fine. So we don't need this weird thing. So we can remove that extractor like that. In fact, maybe we should even do that. How does it look? Nah, it's fine. Let's leave it like this. Okay, and now I believe we should fix a few pattern matches because we're pattern matching on empty like that. Maybe I can mark them like this. There we go. It's exactly 2. That's all good. Next thing that we're going to do is, I prefer to do this on ADTs because I put my case classes inside of a companion object. So what I like to do is we're going to write a quick test here. I'm just going to call it toString because I'm kind of lazy. So I'm going to say that tree empty toString should be tree dot empty, which is not right now. So I'm going to go to tree and I'm going to go to the bottom over here, and I'm just going to do a final override. Final is technically not necessary because objects are final by default, but still override def2string string equals tree dot empty, and another one. I'm going to put it exactly in the same spot. I'm just going to say, okay, so as soon as it's not empty, then I still want to see this prefix, right? So I want to say it should be tree dot non-empty. It's not in scope, so I can't auto-complete it. Non-empty, there we go. Tree dot empty, and then the 1, and then the tree dot empty again, right? And the way we do this is by overriding not toString, but actually overriding something else. If I open a brace over here, it should auto-complete it over there. So it's called product prefix. Remember in the video about case classes, this is we learned about this method, and it's going to be non-empty, and now it's actually going to use it and put it over here, which is kind of cool. All right, so the next thing that we're going to do is we're actually going to modify the add and the remove method on the trees because, as I said, trees, they don't mind having duplicates. Okay, so I've already prepared a bunch of tests for the removal, so I'm just gonna copy them over. Initially, in the preparation for this video, I copied them over from the sets, and then I just changed a few things. So I'm just gonna insert them. Let's say over here. We can go through them real quick. Basically, remove on an empty tree should yield an empty tree. On a non-empty tree should yield a new tree without the element. It's very simple stuff. We did the same thing for the sets. Removes only the element in question, and removes only the element in question, like from the correct side. Also, that add remove combo should ensure that all elements are distinct. Why do I have that one? Oh yeah, so we're adding a bunch of the same elements to the tree, and then we're removing it, and we're making sure that all of them are actually removed. And this is actually the part that we're gonna change. And the last one is that it removes them from both sides of the tree. All right, so I'm gonna save this, and a few of them should fail. I believe. I'm not sure. No, okay, they're not gonna fail, but they will fail as soon as we change add. So if I go to add, and I'm going to say, okay, so if it's exactly the same element as we already have, I want you to add it again. I don't want you to remove that. I don't want you to return that thing untouched. So basically, I'm just going to remove this, right? So what this code is saying is that if the element is the same, right, the equal sign over here, it says if it's the same, just put it on the left. And therefore, when we remove, we need to remove the element from the left before we do the union with the right. So we're just going to do left remove input. So if I don't have that, now because we changed add, the test will actually fail. This should fail somewhere. Yep, one test failed, and I believe this should be the one with the distinction. Yeah, all elements are distinct. So basically, it went over here, and it removed only one of them, right? So in fact, maybe we should just print it out. Let's see, print out tree, and go down a bit. Unfortunately, it prints them out at the top. So this is how it looks like, and it has 1, 2, 3. Yeah, and initially there were 4, so it removed only one of them. However, if we don't need this print line anymore. If we go over here and do that, then all the tests should be green because it will just go to the left branch and remove all of them, and only then unite it with the right branch. All right, so we're actually done with the trees. In fact, if I was working right now, then I would actually create yet another commit, and I would say, okay, I'm done, adding trees. For you guys to, I want you to have like basically this one commit, except for the one that did the refactoring, so that you can easily see like the whole thing that we did in this video. So the next thing we're going to do is we're going to go back to SAT, and we're going to start using the trees. Let me go to the top real quick, like that. Okay, so this is what we have. So what we have is, if I'm going to collapse it, is that we have this abstract class SAT, right? And we have the object SAT, and inside of it we have two implementations. We have non-empty and we have empty. And now the idea is to say that the SAT is not a tree, as we sort of had this, like we had this mixture of a SAT and of a tree. We weren't really sure, is it more a SAT or is it more a tree? And the idea is now to favor composition over inheritance. So the idea is to say a SAT is backed by a tree. So a SAT has a tree. So we're just going to have a constructor. We're going to have a private constructor that will get the tree passed in. So this is what we're going to do. So it's not going to be a sealed abstract class. It's just going to be a regular final class set element, and what it will have over here, it will have a private constructor with a val tree. It's a val because there's no harm in exposing that tree on the to the outside, right? Because it's immutable. So if you want to get it and modify it in some way, what you're going to get back is an entirely new tree, and this set will remain intact, right? But we don't want people to pass in arbitrary trees from the outside, which is why the constructor is private, right? So this is just going to be a tree of element like this. Okay, and what we're going to do now is we're going to go to the bottom over here where we have, I collapsed it on purpose. So we're just going to remove these, this non-empty and this empty. Let me double check what's inside. Oh, it's just the extractor. So we can just remove that, right? Because now SAT is just a regular class. And what we're going to do instead is we're gonna add a private def apply over here because we're too lazy to write new, and it will just basically just do the factory for us, right? It's just going to do a constructor. So we're going to do tree. It's kind of boring. Tree element returns a set of element, and all it will do is it will just say new set of tree, right? Because sometimes we're gonna need to recreate the set from inside of this class, and I think it's kind of nicer because then we don't have to use the new keyword. Okay, so the next thing is what we're going to do is we're going to basically go through all of the methods, and we're just going to delegate most of the calls simply to the tree. Like for example, apply goes to contains, and contains, it used to do this pattern match on which instance of the set do we have, but now all we need to do is we need to just say tree contains input, and that's it. For fold, the same thing. I'm just going to go to tree, fold, pass it the seed, pass it the function, and so on and so on and so on. So for the add, we're actually going to need to make sure that that we check for the duplicates, right? Because remember, now the tree, it doesn't care about duplicates anymore. It allows them. So what we're going to do is we're going to say, okay, if tree, or basically we can say directly if contains input, right? Because contains just goes to the tree contains input. If contains input, then return the set as it is. Otherwise, create yet another set, and this is the private def apply that we created at the bottom. This one, right? So we're just calling, and we'll just create a new set. So let me find it over here, right? Just create a new set with the tree that you have right now with the added input. And by the way, usually I don't like the infix notation, so usually I write it like this, and then I do have input like this. But I also don't like parens. So in this particular case, I decided to use the infix notation, and just to get rid of the parens. It reads nice enough. Okay, for the removal, we don't have to do anything special. We just go straight to the tree and ask it to remove the element. Sat with a tree where this element is removed. Remove input. There we go. Union, we're gonna go to the union as well, and we're not gonna do fold. We're just gonna create another set where we say this tree union that tree. Pretty simple. So most of the time we're delegating stuff, right? Intersection is going to stay the same. Difference is going to stay the same. Subset of all of this is going to stay the same. Equals is going to stay the same. Hash code is also going to stay the same. ToString, this is the key. Like in the toString, what we need to do right now is we don't need to match on this. We want to match pattern match on tree. And again, pattern matching on the tree is fine because the equality for the trees is not as expensive as the equality for the sets, which is why those case classes for the trees, they're public. Maybe I've actually forgotten to make them public. Yeah, I've forgotten. So it's fine to make them public. There we go. So we're gonna pattern match on the tree. So over here we just say if the tree is empty, and over here if the tree is not empty, and over here this tiny helper that we have split by comma space, it's also gonna get the tree and not the set. Okay, let's go down. Okay, so what we have is empty. Is empty is basically if the tree is empty, right? Tree dot is empty. Non-empty stays the same. Is singleton, same thing. We're gonna pattern match on tree. So we're gonna tree match tree dot empty, tree dot not empty. In fact, because pattern matching on trees is less expensive, we can actually have a better implementation of a singleton. So I'm just going to duplicate that just so that you see both of them. So what we can do is we're still going to pattern match, but we're going to take this one, and instead of using the variable over here, we're going to say, okay, if this one is empty, and the right one is empty, right, then basically it means, you know, on the left is empty, on the right is empty, then this is a singleton, right? So it's a true, and otherwise whatever it is, then it's a false, right? So this is even shorter than this, so we can throw this one out like that. And for the sample, it's going to be sort of similar. So first of all, we're going to match on the tree, and we're going to say tree.empty, like that. Then it's a none. Actually, why did we have it in multiple lines before? Tree dot like that, non-empty. Control J to join the lines. What else? That's pretty much it. Unless I've forgotten a few things, that's actually all that we need to do. And if everything is green, no, it's not. 57. There we go. And what else? 87. What is there? Final override def nothing, set of nothing equals empty. Yeah, that's actually not empty. That's a sat. That's a sat of tree dot empty, right? So it's basically, it just calls apply. So let's just call apply. So nothing calls apply, which is why it's at the top. There we go. And now everything should be fine. All the tests should still be green. Our set's got a bit smaller, so it's just 95 lines. The trees have 120 lines, but most of it comes from rendered. So rendered is until here, I think it's 36 lines. So most of it is rendered. But yeah, so basically we have trees around 100 lines and set around 100 lines. And that's pretty much it for today. So let's just open a terminal again and add everything. And I just prefer to add everything, even though it's most of the time unnecessary. We didn't create any new files, I believe. Oh no, we did. We created the tree. So so yeah, that's why I just always do it. 19. So we're gonna call it extracting trees out of sets, from sets, out of sets, like this. All right, and let's also push that. There we go, and it is pushed. Cool. So let's check it out. Over here, the 19 refactoring and extracting trees out of sets. Refactoring is kind of boring. I'm not even actually gonna go through it. Okay, so what we did here is we revamped the set, right? So we basically removed a bunch of things. The set became much shorter. We created trees, completely new file. We added a bunch of stuff to the tree suite. We changed in the tree suite. We switched from using sets to using trees. And yeah, that's pretty much all that we have done today. I'm sorry that this video was not like super exciting as before, but at least it got shorter. I'm actually kind of enjoying making the videos that are shorter. I'm sure you guys enjoyed it as well. Most of my videos in the past, they were like 1 hour long, and especially those videos about trampolines, they also were kind of heavy, So I'm actually enjoying like doing like rather simpler videos. Let me know what you think in the comments below. And yeah, that's all I got for you today. In the next video, we're gonna do maps. Yeah, it's been Vlad, devinsider.com. Like this video if you did, subscribe if you want to improve the developer inside you. Most importantly, take care.